let's get started. Continue on chapter 2. Like I said, planned here, we should have plenty of time to finish chapter 2 today. But like I mentioned last time, one of the most important part, actually maybe 70-80% of your next quiz will be the reactions of alkenes. Okay, the reaction of alkenes. We have a lot of examples in your notes, and also we have extras in my PowerPoint. So make sure to watch the video and practice them again and again and again, so we get a full idea about how to work on these reactions. Okay, most times I will give you a reaction, give you an arrow, and you show me what the products are. Sometimes there are some variations about how I will ask you questions about these reactions. Okay, let's take a quick look about what we studied last time. The reactions about alkenes are called addition reactions. Basically, we convert a double bond to a what? To a single bond, right? Then we have two species on these two carbons. Again, your focus are only on what? These two carbons. The rest of the structure, please what? Copy. Okay, copy. And if the species added to the double bonds, two carbons, are identical, such as hydrogen, chlorine, or bromine, then you don't have to worry about which one goes to which carbon. But if they're not identical, with hydrogen as another X, the X could be bromine, could be chlorine, could be OH, could be water, right, from part of the water. Then you have to take a look. If these two carbons are different, then the hydrogen would be preferred to be what? To be added to the carbon with what?
More hydrogen.
More hydrogens. So your favorite product, favorite means preferred, you get more of it, will be the one with hydrogen added to what? To the carbon with more hydrogens attached to it. So this one, again, is the favorite product. Okay, favorite product. And we call that rule Mark's rule. Okay, and we did two exercise here. Okay, make sure again, these are very good exercise for you to explain. Okay, first, why we get these two types of product, and then why hydrogen is added to one carbon preferred instead of the other. Okay, instead of the other. So this is what we studied last time. Okay, and this class today we have a final reaction to study about alkenes, which is also addition, but the addition reaction is a little different. It's a little different. So let's take a look on board. Okay, let's say I have a very simple alkene. Okay, this is the simplest alkene with only two carbons. We call it ethylene. Okay, ethylene. Now, if you take a look at the alkene, normally we said if we want to carry out some addition reaction, we first need what? Change the double bond to what? To a single bond. Then we add what? Some X here and some what? Y here. Is that right, guys? This is what we did. All for the first four reactions. Now, in this reaction we're going to study, okay, we're going to study today, instead of adding X and Y, those simple atoms or species, the alkenes, okay, the alkenes can add to themselves. Okay, can add to themselves. So let's see, I draw this on board, so hope you can see it. So let's say this is the alkene. On this carbon, there's another alkene added to it. On this carbon, there's another of the same alkene added to it. Do you guys see that? CH2, CH2, right? This is the alkene. Remember, this one was from what? From this guy. Is that right? We started with this guy, right? Change the single bond to what?
Single.
To a double. Change the double bond to what?
Single.
To a single bond. And then on this carbon, I added to what? To itself. Do you guys see that? On this carbon, I added to what? To a self. You guys said it's not the self, it's a double bond. And you remember, if you want to add something, the double bond always has to become a what? Single bond. So basically, you can imagine like me as the alkene. One bond, another bond. In order to add to myself, I need to what? Open a bond to a single bond. Then I hold the same me on the left and hold the same me on the right. I can have a lot of me on the left side, a lot of me on the right side. So basically, I can add a lot of myself to make a what? Chain of it, long chain of it. This is just showing you three of them. On the other hand, I can add another one. Okay, another CH2, CH2. Okay. You guys see that? Many of them. Okay, but each here, sorry, CH here is from what? From an alkene. You guys see that? The only difference is what? The double bond becomes a what? Single bond, because they want to add to each other. We call this reaction, okay, we call this reaction polymerization reaction. Okay, polymerization. And because this thing, you can see that, this is very long. This is only 4 pieces of it. Okay, this is very long, a million molecules. So how do we represent the structure? I put CH2, then I put a parenthesis, use a subscript N to show people the structure. The N means what? A lot of these things repeating what? Together, one at a time. Okay. So this is what the structure is showing. And of course, if you wanted a lot of this repeating N number, the N again can be millions, billions of repeating. If you want an N number of repeating inside the parenthesis or repeating like a me, you need what? You need to start with the same number of what? Myself. Right? 100 of me, then inside this piece, the length is what? 100 me. If you have 1,000 of me, then inside the length will be what? 1,000 repeating pieces. Okay, so this is the reaction showing polymerization reaction. These are called monomers. They're single units, right? And they have what? Double bond. Is that right, guys? These are called polymers. What's the difference? The double bond becomes what? Single bond. You can see the bond is outside the parenthesis, showing people what? There are a lot of units repeating, linked together. Very long. Okay, I think here is showing 4 pieces. Inside the parenthesis, there's like a millions. The molecule is huge. Okay, molecule is huge. And this is a picture showing this polymer. You can see that plastic beads. Okay, plastic beads. Of course, this is the initial product. You guys might wonder what they're used for. Okay, the same thing, polyethylene, what it's used for. You guys use them every day. Okay, and shopping bags are actually polyethylene bags. Okay, this is what we just did on the board. This is exactly the same thing, polyethylene. Okay, shopping bags. All kinds of shopping. They have different colors. They're added colors. Okay, some white plastic, the regular color is colorless or plastic white color. Okay, they're not degradable. Okay, these are tough, very just permanent. If you bury in the landfill, will just stay forever. Okay, they're very tough, but they're not degradable. Okay, so this is the last reaction we study about alkenes, called polymerization. Now this is one type. Okay, starting with this guy, the simplest alkene, CH2 is a double bond. We can change one of the hydrogen to a group. Okay, for example, shown here, I can change one of the hydrogen to a Z. Z can be anything, can be a lot of things. And then we do the polymerization the same. We end up with different types of plastics. Okay, remember I said this one, you end up with a shopping bag type of plastic. And you can change the monomer to a different type of alkene. Again, one of the hydrogen is replaced with a Z. Z can be in groups. But you can see the reaction is the same. You guys see that? Monomer is what? Double bond, right? CH2, CH double bond. There's a Z. Z can be in groups. After that, the polymer is what? Single bond. Everything else is the same. You're not changing the number of anything. All you need is what? Put a parenthesis and put a subscript. N means what? Repeat. That means a lot of these things are adding to each other. Okay, adding to each other. Okay, CH2 is still CH2. CH is still CH. You're not doing anything. You're just repeating these together. Okay. So I'll show you a few of those with different types of Z's. The first type is if Z is a benzene ring. See that? The polymer is like this. You guys see that? Right? Double bond becomes what? Single bond and parenthesis N. And this monomer is called a styrene. Okay, the polymer is called a polystyrene. You guys know what? Have heard of polystyrene, right? What is polystyrene? This is polystyrene. Your shopping phone, sometimes your coffee mug in the morning, the disposable one, the white one, is made by this polystyrene foam. Okay, it's very sticky, the polystyrene. Okay, and this table showed you other types of monomers, polymer, and what they're mainly used for. Okay, this is styrene. Okay, this is Teflon. You guys have heard of Teflon too? Different types of plastics. Okay, they're all from alkene polymerization reactions. Does it make sense, guys? Okay, take a look at the table. Again, what is structure between the monomer and polymer? You can see the difference. Great. Monomer is what? Double bond. Polymer is what? Single bond. But everything else is the same. The only you need to worry about is whether it's the polymer or monomer. Polymer is the double bond. Monomer is what? Single bond, and you put a parenthesis and put an N. N means what? How many units are repeating in there. Okay, you don't care. It's a big number. Okay, it's a huge number. Okay. And they have different uses for these polymers, for these plastics. And this one, by the way, is called a vinyl chloride. So this is called a polyvinyl chloride, PVC. Okay, you guys have used PVC, right? Everyone has PVC under your sink, the white pipe. You open down your sink, you the white pipe. What are the pipes are? This is PVC pipe. Okay, most of our houses use PVC pipes now. Okay, nowadays. Okay, so in this one show you how you recycle them, and they have different recycling code. If you're interested, you can take a look of them. And here's the summary of the reactions we studied in this whole chapter. Okay, in this whole chapter. Okay, 5 reactions. Okay, 5 reactions. First is adding what? Hydrogen. Second, adding halogen. Can be bromine, can be chlorine most times. And third one is adding HBr, HCl. Fourth one is adding what? Water, HNOH. So remember, if you're adding HX, okay, HX, you need to follow what? The Marx rule. So that the hydrogen is preferred to be added to the carbon with what? With more hydrogens. And finally is the polymerization reaction. Okay, polymerization reaction. They're all addition, okay, but this is a unique type of addition. They're adding to themselves like limitless way. Okay, make a long chain. All right, questions before we move on to talk about CC triple bond? Any questions? Good. Next. Okay. Let's take a look. CC triple bond. We'll only spend a very short amount of time, a few minutes, to talk about triple bond. Okay. First is, what is a triple bond? Okay. Before that, let me ask you guys one more time. So far, we have studied 2 types of carbons. In chapter 1, we studied a carbon in which the hybridization is called sp3, right? That means most carbon-carbon are bonded to each other, or carbon-hydrogen bonded through sp3. Most carbons are sp3 hybridized in organic compounds. And an sp3 carbon is what? Tetrahedral, right? 4 bonds, okay, 4 single bonds, because the sp3 carbon is in single bond, right? And then when we studied double carbon-carbon double bond, we studied what? sp2 carbon, okay, s2p carbon. And for sp2 carbon, there are 3 sp2 orbitals. That means there's a perpendicular p like this. Is that right? So when they make a bond, they can make a sigma bond or what? Or a pi bond. That's how a double bond looks like. A sigma bond and what? And a pi. Sigma is end-to-end overlap. Pi is what? Parallel overlap. Okay, this is sp2. When carbons are involved in double bond, they're sp2. So today we're going to learn the last type. Okay, we don't have a lot of types. Okay. When carbon-carbon are in the triple bond, there's a new type of carbon. Okay, new type of carbon. Still the same scheme. You can see this is the carbon orbitals, carbon atoms. In triple bond, the carbon only uses 2 of them to hybridize, to mix. One here, one here. If you use 2 of them to hybridize, you end up with what? 2 new ones. And this 2 new orbitals are called sp hybridization. Why sp? Because you only use what? One of the s, one of the p. That's it. And these 2 are not touched. They're not hybridized. Okay, they're just remaining the same. So you still have 4 orbitals. You start with 4, you still end up with 4. But 2 are hybridized ones. The other 2 what? Are the original one not used. Still each one has a single electron. We call this type of hybridization sp hybridized. The sp. Now what does a sp hybridized carbon look like? Look like this. Okay, the light green ones is the sp How many sp? 2. So like this. If my fingers is a carbon, there's one on the left, on the right. Or you can say one on the top and bottom. Doesn't matter. They're straight. That is why sp carbon, the geometry is linear. What linear means? Straight. Left and right, top and bottom, front and back, whatever you call it. Okay, linear. This is sp and sp, 2 sps. The green ones. You guys see that? Now there are 2, we said there are 2 what? Not hybridized. Where are they? They are perpendicular to both of them. Okay, one is perpendicular like this, another one is perpendicular like this. So if I said the SPs are left and right, then the one that's the perpendicular will be top and down, and what? Front and back. You guys see that? Look like this. Each carbon look like this. Okay, each carbon look like this. Okay, can you come back and help me? Okay, I'll show you guys what a triple bond looks like. Okay, you do the same thing with me. Okay, do the same thing with me. Here. You do the same thing I can do. Again, this is SP, right guys? And this is one perpendicular, and another one is perpendicular like this. Okay, you can use 2 hands. You're right, good, perfect. Do you guys see that? This is SP, this is SP, right? SP and SP, right? And we know one is perpendicular like this, another one is perpendicular like this. The whole thing is what? Perpendicular, right? So this is one carbon, this is another carbon. See how we overlap? When we overlap, these 2 SPs make a bond. We call this bond is what? Sigma bond. You guys see that? End to end. Is that right? But when these 2 make a sigma bond, what happens to these 2?
They make a pi bond.
What type of bond?
Pi bond.
Pi bond, because they're what? Parallel, right? And how about these 2?
Another pi bond. Another
Still what?
Pi
Pi bond.
bond.
You can see that? That's how we have a triple bond. One is a what? SP and SP make a what? Sigma bond. Another 2 pairs of what? P's, because they're parallel. This one is parallel. This one is what? Parallel. So we have 2 pi bonds and what? And a sigma bond. Thank you guys. Okay, 2 pi bonds and a sigma bond. And here is the picture, shows you how the 2 carbons overlap. Okay, SP, see the light green ones, they make a what? Sigma in here, along the line, along the axis. And then there's a pi, P here, they do what? Parallel, pi. Another P like this, pointing straight in, they what? Do another what? Parallel. So that's a triple bond. This is a CC triple bond. Okay, triple bond. There's a sigma bond and 2 pi bonds between 2 carbon atoms. Okay, 2 carbon atoms. And we said, because the SP geometry is what, guys? I mentioned earlier, what is the geometry of SP?
Linear.
Linear, right? So these 4 atoms, C, C, H, and H, is what?
Linear.
Linear. The molecule is straight. If you only have 2 carbons, this is what molecule looks like. See? It's linear. See that? This is the triple bond. That's the SP. That's not the SP. The middle one is the sigma, if you can assume. Then these other 2 are pi bonds. All molecule is what? Straight. Okay, very nice straight one. Okay, this is SP, SP. Okay. You guys see that? Only a few take-home notes, like I said. You don't have to explain to people how you made an alkene. This first, what is the hybridization for triple bond? SP hybridized. Right? What is the geometry of SP? Linear. Okay, the molecule is linear. That means when you have a triple bond carbon, make sure the 4 carbons should be what? In a line when you draw the structure. And number 3, what is a triple bond? A sigma bond and what? 2 pi bonds. Okay, 2 pi bonds. That's it. That's all you need to know. Okay, you don't have to explain exactly what hybridization is. Okay? Next. Okay, next. How do we name alkynes? Okay, how do we name alkynes? Very fast, 1 minute, we can explain how do we name alkynes. The naming of alkynes is exactly the same as naming alkenes, except Y and E is what? Used to replace E and E. That's it. The only difference that is that. Everything else is the same. Okay, so take a look at the name, guys. Okay, follow the rules and think about what the guidelines is. First step is what? Find the longest chain, right? Containing what?
Triple bond.
Triple bond must include these 2 carbons. Number 2, what? Number the longest chain so that these 2 carbon gets what?
Lowest number.
Lowest number. That's 2 are the function of the triple bond carbon, 1 and 2 gets lower number. Then, when you name the longest chain, you need to locate what? The triple bond using what? The lower number. Where's the triple bond here? 1 and 2. So I need to locate it using the lower number 1. The name of this chain is called what? 1-butene. Why 1? Because the triple bond is between what? 1 and 2. And besides the longest chain, again, after you put a pencil here, you know there's a group.
3 methyl.
Which is what?
3
Methyl group on number
3.
3. So 3-methyl-1-butene. You guys see that? Take a look at this name. See if you can understand. If it doesn't make sense, just show free. Don't be shy. Okay. You can see you 8 of you are doing great. I don't think the other 2 can show up. Even if they show up, they won't catch up. Trust me. The first chapters, if they miss, it's very hard to catch up. So you're gonna 8 of you gonna work together, fight together. See if in the end you win or I win. If you all get A, you win. Good? The name makes sense? Yes, yes.
I have a question.
Yeah.
On the 3-methyl 1.
Yeah, no butane.
Never mind, I just actually.
Got it?
Yeah.
Okay. 3, it means again, here we take priority of these 2 carbons. They get lower number.
Right.
So that one is 3 because these 2 get 1 and 2.
So alphabetical, does it mean we don't do? So the one butene, 1.
Yeah.
Because it's never mind.
1-butene means you have to put a number here.
Okay.
That number tells people where is this triple bond. Just like when you're naming alkenes, you have to tell people where's the double bond, the same. You have to tell where is the triple. 1 means there's a triple bond between 1 and what? 2. That 1 is the location of the triple bond. Okay, just like this 3 here. 3 means there's triple bond between what? 3 and 4.
So it's the name of like how many molecules there are in things, so that's why it's always at the end regardless of alphabetical order, because it's the name like before. So that's why.
Right?
Yeah.
Is that what you're?
Yeah.
Okay.
I kind of answered myself after I
Okay.
got it.
Alright, next. Okay, next is the isomers of alkynes and also showing you how to draw the structures, skeletal. Okay, skeletal structures. Most important is the skeletal structures. Okay, first is alkynes don't have geometric isomers. You don't have to, there's no cis or trans for alkynes. Okay, that's number 1. Number 2 is when you draw skeletal structure of alkynes, take a look. The 2 alkyne carbons and the whatever the carbon bond atom is bonded to the alkyne has to be what? Linear. You guys see that? 1, 2, 3. These 3 are in the same line. The other ones don't have to. These 3 or 4, depends where it is. Like this one is in the middle, so 1, 2, 3, 4. These 4 carbon has to be what? Linear, straight. Okay, straight. The other, this one is not, because this carbon is no longer sp3. This carbon is what? No longer sp. This carbon is what? sp3 now. Okay, owning these 4 or these 3 depends where. There's a hydrogen here, still straight. If you want to make sure, if you want to see there's a hydrogen here, still line straight. So make sure again, for triple bond, okay, triple bond, the atoms directly bounded to the triple bond carbons should be in a linear geometry when you show the structure. Does it make sense? Okay, because the molecule is what? Molecule is linear. Okay, molecule linear. And of course, the picture shows the triple bond can be at different locations. Okay, different locations. Okay, give you a couple minutes, see if you understand the names too, with skeletal structures. And also triple bond is a little unique. You can see that there's a carbon here. Okay, even though there's no turn, because there's a triple bond, you know there's a carbon here, there's a what? Carbon here. So here, all here is what? 4 carbons, adding 5 and 6. So the whole line is what? 6 carbons. Okay, 6 carbons. Okay, that's how we draw a triple bond because there's no turn. Why? Because the molecule is what? Linear. That's why you cannot make turns. Okay, you have to show like this way. Okay, it's a little unique for triple bond. And if the triple bond is then terminal, again, guys, there's a hydrogen here, right? Remember, there's a hydrogen here. We just don't show it. But this is number 1 carbon. Okay, number 1 carbon. Okay, take a look. If the names of triple bond of these alkynes
So
make sense
that
too.
one that you just shown, with the 3 methyl there, so at the top.
This one?
Yeah.
Yeah.
So there'll be a hydrogen on the left-hand side,
On here.
yes.
On this carbon, yes.
And then there's a carbon,
Carbon,
yes.
hydrogen,
Hydrogen.
carbon,
Okay.
carbon, 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 carbon.
Oh, so there is.
There's hydrogen here, we just didn't show it.
Okay, so there's a carbon there as well, right?
There's a carbon here, of course. The end is always a carbon.
Yes.
Yes,
Okay.
end is always a carbon. It's just this carbon is a CH, right? There's a hydrogen on this carbon. Does it make sense, guys? You can put the, for example, let me put this. Okay, you can put it in a little bit expanded structure. That's the what molecule is. The top left one, top right one. Sorry, top right corner. This one is what the molecule is. Carbon with a hydrogen on it. Carbon, carbon, and on this carbon there are 2 methyl groups. Make sense? For skeletal to expanded. But you can see that these three carbons are what? Linear, right? All 3 should be 1, 2, 3 should be in the same line because that's what SP geometry is. Does it make sense, guys? Naming, structure, any questions? Okay, finally, okay, something, if you're interested, you can read, I don't require, is the physical and especially the chemical properties of alkynes. Okay, you won't see any reactions about alkynes. Okay, I just want to show you. The reaction is similar to alkenes, but the addition is more difficult and somehow, and also you need to double the amount of the addition reagent. But again, you won't see reaction of alkynes in your tests, okay, in this class, just for you information. Okay, physical properties are similar, like we talked about earlier, right? Physical properties of all hydrocarbons are similar. Okay, so you don't have to study the physical property of alkynes as an individual type of molecule. They're all similar. But chemical properties, chemical reaction alkynes are not required for this class. Good? See, very short for alkynes. Okay, naming and what is a double bond, most important. Good? Okay, let's move on. Next. Okay, next. Is some of you have been asking me over the weekend one of the word you see in your lab called aliphatic. Okay, what is aliphatic? Okay. Aliphatic compounds. Okay, aliphatic compounds are basically all of the compounds we have studied so far, all the structure you have seen so far in our lecture notes, in your books, including these alkane, cycloalkane, alkenes, or alkynes, all the compounds we have seen are classified as aliphatic compounds. This word is created to distinguish these compounds from this type. Okay, from this type. Called aromatics compound. Okay, aromatics compound. And which is we're going to study in the second half of this chapter. What are aromatic compounds? Okay, again, what is aliphatic? It's anything you have seen so far. The linear one, the chain one, the rings are mostly aliphatic compounds. Okay, I don't even know how to explain what is aliphatic. It's just these are all aliphatic. Okay, they are created. This word is basically to show you These compounds are different from what? Here. Or this should be, I should say this way. This compound, this types of compound are so different than these we have studied. Okay, that's why we have two types of hydrocarbons. Now, aliphatic hydrocarbons and here aromatic. Okay, aromatic. Okay, this aromatic, the word coming from aroma. These compounds normally have a smell, okay, the odor, either pleasant or unpleasant, but they have a strong odor. Okay, they have odors too, but these are also odors related to some scent, some fruits, etc., etc. So that's why people gave it the aromatic compound word. Okay, now the simplest aromatic compound. Okay, the simply aromatic compound is shown here. Of course, this is the expanded structure. Show you everything. Is a 6-carbon ring. Okay, 6-carbon ring with alternating double, single, double, single, double, single bond. 6 bond, of course. 3 double, 3 single bonds. And each carbon has only what? 1 hydrogen attached to it. You can see that the number bond is 4, each carbon. Again, this is the simplest aromatic compound. We call that benzene. Okay, a benzene. The name of this compound is a benzene. Okay. In organic chemistry, the definition of these compounds is a little different than we talk about this class today. But to simplify things, I just want to show you what are aromatic. Well, aromatic are structures with this moiety or multiple of these benzene rings fused together are called aromatic compounds, and this is the simplest. And some of you may have questions. Now, you said this is alternating double, single, right? Remember we studied earlier, what type of compound has what? Has double bond? Alkenes, is that right? So you may wonder, why these are not alkenes? Why they are so unique? They're called separate type, right? We classify these are separate type. The reading is, we're going to say it right away. These compounds, even though structurally we show it like double, single bond, but in fact, these compounds will never react as alkene. They don't do any reactions like we studied before, alkene reactions. They don't never react as an alkene. That's why they're a different type of compound. Okay, here's the type of compounds. Here are the structures. Okay, structures, you can see that. This is the expanded. We store the skeletal. Okay, skeletal. If you notice that the double single can actually what? Shift. You guys see that? Double single. But I can shift it over, so make this one to single, then this one becomes what? Double. So still double single. So we can see these two are basically the same. So sometimes, in order to show people, or instead of using this, I can even just put a ring inside this hexagon. They're the same thing. They're all the same. Okay, and also, this ring tells people what? These are different types of compound. They're not what? Really double bonds. Okay, they're not really double bonds. Because the double bond doesn't belong to these 2 carbons. They can be here too. Okay, there's a whole ring. They share the 3 double bonds and 3 single bonds. Okay, now what is the structure? Okay, what does the structure really look like? Okay, in benzene, each carbon is sp2 hybridized. Okay, there's no new hybridization. Each carbon is sp2. So think about it, they're a double bond, right? If they have kind of like double bond, so carbon is what? sp2. Okay, we know sp2 carbon look like this. So each carbon look like this, right, guys? This is what each carbon look like for sp2. But when they make a ring, think about it. When they make a ring, so that means 6 of the p orbitals will be what? Like this, is right? Every p is what? Perpendicular to the plane. So there are 6 of them. So the 6 of these p orbitals make a big pi bond, like a sandwich above and below the plane. Remember, when the p orbitals are all perpendicular, they're what? They're making pi bonds. But the pi bonds doesn't belong to any 2 carbons particularly. They belong to what? A whole ring. You guys see that? There's a p here. There's a p here. There's a P here, P here, P here, P here, P here. There's 6 of them. So when they make a pi bond, they don't just make between 2 carbons. They make what? The whole ring. The pi bond belongs to the, see, there's 6 of them. And these 6 of them make a huge pi bond what? Like this. 2 sandwiches above and below the ring. And because of that, benzene, all the bonds length are the same actually. You see there's some data showing you that. Okay, a double bond should be 135 length. A single bond should be 147. But the bond for benzene is between single and double is 140. And they're all the same. 6 bonds are the same length. Showing what? The structure is like this. The whole pi bond belong to what? Belong to the whole ring. Not belong to any 2 carbon atoms. Okay. And because of this extra pi bond, okay, big pi bond, benzene ring is very, very, very stable. It does not react with any addition reactions, okay, under regular common conditions. Does it make sense, the structure? Okay, each carbon is like this. Okay, there is one thing perpendicular to the plane. So if you have 6 of them, those are 6 like a pillars supporting the house. Okay, more stable than only 2. Okay, only 2. And again, technically speaking, there is no single double bond. It's a what? It's like a half bond for between each 2 carbons. Why? Because it's double, single, right? Each bond could be double, could be what? Could be single. So kind of between single and double is 1.5. That's why we use the dashed lines. Do you guys see that? Everybody is the same. This not to say this is double, that's a single, or that's a double, that's a single. They're all the same. That's why you have a what? Draw a circle inside the ring. That's how what the benzene looks like. It's very stable because of that fact. Okay. And also, some stories in history in chemistry is people actually spend years trying to figure out what the structure of benzene. You can see that different chemists proposed all kinds of structure for benzene until nowadays. Okay, nowadays these 2 structures are common accepted structures. They propose a lot. They know benzene is C6H6 for a long time, but nobody knew what the structure was. Okay, what the structure was until what? 1899 and 1865. Those 2 proposed these 2 structures. They're still used. Okay, they're still used. One is a double single structure, what we use a lot in organic chemistry. Another one is showing the real reality. Okay, there's no double single with what? Kind of 1.5 between all bonds. Good? That's how benzene. What is the benzene? Benzene is 6 carbons, 6 hydrogens in these structures. Okay, it is very highly unsaturated, if you think about it. Okay, think about it for alkane. How many hydrogen there should be if it were an alkane? For 6 carbons, how many? If it is alkane, how many hydrogens there should be?
14.
How many?
14.
14, right? How many hydrogen here?
6.
6. Think about how many hydrogen short. 8 hydrogen short from what? For alkane. Alkane is called what? Saturated, right? These are 8 carbons short. That means what? It's very, very unsaturated. Okay, very, very unsaturated. All right. Next is probably the only topic we'll talk about benzene for you guys to know is how do we name benzene derivatives. Okay, mostly how do we name if there are groups on benzene rings. Okay, first, okay, very important for you guys. How many hydrogens are on each carbon for benzene?
1.
How many?
1.
1. Is that right, guys? C6H6 means what? There's only 1 hydrogen on what? Each carbon. So if you want to put a group on the carbon, that means what? There's only 1 hydrogen for you to what? To replace. So, in another word, each carbon of the benzene ring can only have how many groups?
1.
1. There's no way you can put another group on the same carbon. Does it make sense?
Right.
If you want a different group, you have to choose a different carbon. for one particular carbon on the benzene ring, you can only have what? Maximally one group. That group will be replacing the hydrogen. Does it make sense? Okay, that's for sure. Okay, when you draw the structure, you know if some structure show you two groups of the same carbon, that's wrong. That's benzene cannot do that. Okay, cannot do that. So first is if you have one group only in the benzene ring, how do we name this? Okay, naming of these compounds will be very easy. Just use the name of the group as a prefix followed by the name benzene. Okay, take a look at the four names. Fluorobenzene, chlorobenzene, isopropylbenzene, and ethylbenzene. You can see that? Use the group as a prefix and name what? Benzene. These are all benzenes. Easy? That's first guideline. Okay, first guideline. With 7 guidelines. 6 or 7? 7. Okay, first guideline. Now, that's when you only have one group. Okay, one group. If the group attached to the benzene ring are one of these four, okay, one of these four, or are like these four structures, they also only have one group. But if you see these, then we do not use guideline 1. We don't name the group followed by benzene. Because of these four groups, the name of these molecules becomes a new name. We don't call them benzene anymore. They become a new parent name, actually. We'll see them again in guideline 4 and 5, or 5 and 6. For example, if a methyl group attached to the benzene ring, we don't name it as a benzene. We name the whole thing toluene. If OH attached to benzene ring, we don't call it benzene. We name this whole thing with OH, whole thing, call it phenol. This one is called aniline with NH2 group. This one is called benzoic acid with COOH. We will see that in chapter 5. Okay, we'll see that in chapter 5. We'll see more of this group in chapter 5. So, if you see any of these four compounds, they're no longer named as benzene. They have their new names. Okay, these new names will be the parent name. We include what? Include everything. Include everything. And we'll see these again, but memorize these four names. Toluene, phenol, aniline, and benzoic acid. Okay, benzoic acid. I know some of the words look weird, but they're pronounced just like what they are. So it should be, you don't have to pronounce anything in your test. Okay, benzoic acid. Next, if the group attached to the benzene ring, like this group, see that? Is too big to name. You cannot name the group, you don't know what the group is. Then we do the other way. Instead of using this one as a group, I use the benzene ring as a group. We know benzene ring is what? C6H what? 6. So how do we get a group? We take a hydrogen off to make it what? C6H what? 5. And the group will be like this, of course. You attach to somewhere, right? There's no hydrogen here, you attach to it. And the group from benzene is called a phenol group. Okay, phenol group. Still in what? YL. You guys see that? Taking a hydrogen away from benzene, you're creating a group from benzene called phenol group. Okay, phenol group. It's C6H5. Okay, C6H5. So now if this is a group, we can name this molecule just like we did before, right? Longest chain is what? 7 carbons. 7 carbon is what? Heptane. And there's a group, phenol group on number 4. So 4 phenol heptane.
How do you get the number 4?
1, 2, 3, 4. 1, 2, 3, 4. So
Oh, okay.
either way it's 4, right? 4 phenol heptane. Make sense? Okay, it's still one group attached with benzene, but this is a big chain, so we don't name as a benzene. We what? We do the opposite. We use this one as a what?
Functional.
As a group. Okay, as a group. The same here. We don't call these two the benzene. this is the parent name, cyclo what? Butane. And there's two phenyl group on the same carbon, so 1,1-diphenyl what? Cyclobutane. Does it make sense, guys? Okay, so you can see that 1, 2. Let's go back to 3 guidelines. You will see why some are different, why we do that. The first one is, if you have a group, you can name it. Simple. Then you just simply name the group as what? As a prefix for what? For benzene. If you have one of these 4, they all become a new parent name. Okay, no longer benzene, they're called their own parent names. And number 3 is, if your group is not a simple group for name as a prefix, then you do what? Do the other way. You use benzene as what? As a group.
So is there a rule that the carbon should be more than the benzene ring, or
No.
it's just
Depends how you name it. I mean, if you can name that one, there is a way to name that group, but normally we don't for a longer chain. But for carbon, 3 carbons, usually either way works. Okay, either way. And if both are IUPAC names, so there's no rules how many carbons you need cut off, like naming which one is. It depends. Okay, either way should work. Good? Okay, next. Guideline 3 is 1, 2, 3 is about one group. Okay, let's take a look. Guideline 4. If we have 2 groups on benzene ring, okay, 2 groups on benzene ring. Now we said earlier, if we have 2 groups, these 2 groups should be what? On different carbons. Never on what?
the same?
On the same carbon. Okay, yeah, now if they're on different carbons, think about it. There's 6 carbons in total, it's a ring. So the 2 groups could be either what? 1 and 2, or what? 1 and 3, or what? 1 and 4. That's it. There's no this. If you hear it, it will be 1 and 3 again. So owning 3 relative locations for benzene derivatives with 2 groups. Okay, with 2 groups. 1, 2, 1, 3, and 1, 4. And for these 3 relative locations of these 2 groups, we have some prefixes to indicate that relative location instead of using numbers. If there are 1, 2 location, we call this type of location ortho. You can use O, normally italic O. Indicate what? 1, 2. If they're 1 and 3, we call it meta, using M. If they're 1, 4, we call it para, using P. Relative locations. Some of you may ask, can we still use numbers? Yes, you can still use numbers. Either way, but there is an advantage of using letter instead of numbers. That is, when you use letter, think about it. Do you need to worry about which one is 1, which one is 2? You don't, right? You only care that are what? 1, 2 relation. You don't need to worry about, do I wrong name this one 1 or that one 1? You don't need to worry about it. The same idea for meta and para. So again, numbers are fine. Numbering is just like we did before, fine. But using letters will get rid of the time used for what? To number these 2 carbons. Which one is 1, which one is 2. Okay? For example, here are 3 dibromo benzenes. Okay, dibromo benzenes. Take a look at their name. Okay, O dibromo means what? 1, 2 dibromo. Okay, M dibromo means 1, 3 dibromo. 1, 4 dibromo means P dibromo. Good? Next. If you have 2 groups on the benzene ring, but one of the group makes one of the parent name we studied in guideline 2. Okay, if one of the 2 groups basically imparts a special name of the compound. What's special name? Check guideline 2. If that's the case, the name of the compound won't be benzene, but what? But with one of the special names. If that's the case, the group that imparts the whole thing with a new parent name will be bonded to number 1. The carbon with that group will be considered number 1 carbon. Then whatever the other carbon will be numbered by counterclockwise or clockwise. Okay, for example, I know it's long. Take a look at this mark. Okay, there are 2 groups. One is what? Methyl. One is what? Bromo, right? And we know if there's a methyl group on benzene, this whole thing is numbered at what? Toluene. Is that right? So this whole thing is toluene. All you need is number this guy, bromo, which is what? 4. So 4 bromo what? Toluene. Or you can call it P bromo toluene. What does P means? 1 and what? 4. You can call it P bromo toluene. The same. Does it make sense, guys? Okay, you don't name a benzene because toluene, this word includes what? The benzene and what? And the methyl. Does it make sense? When you call toluene, these 7 carbons on my hand are done. All you need to name is what? The bromo. Does it make sense, guys? And the same thing for 2-ethyl toluene. Okay, 2-ethyl toluene. Okay, this methyl make it toluene, and that's number 1 carbon. Then the ethyl will be what? 2. And also you can call it what? O-ethyl toluene. Okay, O-ethyl toluene. And the other rules are very easy to understand. Okay, if there are 2 groups and none of them imparts a special name, then you just simply list these 2 groups in an alphabetic order and then name as a benzene. Okay, name as benzene. Derivatives. Okay, and take a look at these 2 names. Okay, these 2 groups are listed alphabetic order: chloroethyl or bromochloro. Okay, bromochloro. Benzene. And finally, if you have 3 groups, okay, 3 groups, just make sure the groups gets the lower number as possible. And then again, still list the groups in alphabetic order and just name using the rules we have done. Take a look at these 2 names with 3 groups. Make sense? Okay, take a look at the names for guidelines 6 and 7. Let's make sense. If not, I'll go back and forth. Okay, 1 chloro and 2 ethyl what? Benzene. Why 1 chloro? Because chloro start with what? C. Here, 1 bromo, 3 chloro. Why 1 and 3? Because 1, 2, and 3. Bromo start with what? B. So that's what we call this carbon what? 1 bromo. Make sense, guys? Okay, guideline 7, take a look. Okay, the first one has 3 bromo. 1, 2, 3, 4. So it's what? 1, 2, and what? 4. Tri-bromo what? Benzene. This one, bromo start with B, so this one is 1. So that's 3 and what? 5. 1, 2, 3, 4, 5. See that? So 1 bromo, 3, 5 dichloro what? Benzene. Okay, those are 7 guidelines. Again, practice the names in the note first. Okay, then homework and also I think number 4. I have some practice here for you guys too. All right, take a look. I'll ask you guys these 4 compounds. How would you name them? The first one. Anyone? You can take a picture. You can draw it down, or you can practice. I'll give you some time actually. Practice. Right? You can draw it on if you, I don't know if you have it in your notes. If not, draw it. Blank space. Okay, again, how to draw benzene? A hexagon with what? Double single bond. Or you can draw a circle. Either way for you guys. Okay, you can draw a circle or you can draw a double single alternating. 3 double, 3 single bonds. Or you can draw a circle. practice joining them. Good. Very good. I like you guys drawing this. Very, very pretty. Don't forget the double single. Okay, if you don't put a double single, that's not benzene. That's important. Okay, don't miss those. Okay, absolutely don't miss those. If you don't put a double single, they're what? They're cyclohexane, right? Not benzene. So make sure first complete the benzene and then add the groups on the benzene ring. The groups. They're fine. I don't judge, but that's it's go straight. You see that when I have group, they're either straight or straight up. They're actually always straight. That's how the see that. This is the carbons make the ring, right? Make the hexagon. The other one will be what? Up straight, right? If you do like this, these two carbons, the other one will be what? Pointing northeast. So they're actually all directions. Yes. Yeah. There we go. Yes. Okay, and if you have named them, let me see. Let me see it.
I think I'm done.
You done?
Yes.
All four of them? Z. Z-E-N-E. Yes. Very good. Great. Very good. Very good. Okay, try to name them. I can show you. Very good. I haven't seen the last one, but yeah, that's good. Something missing. What is it? Missing. There we go. I'll protect that preference. All right, guys. Okay, let's take a look. The first one. Okay, first one. This is the single group, right? How many carbons? 3, right? 3 carbon group is called what? Propyl group, right? So the name is what? Propylbenzene. Or if you want, you can name this is the chain as propane, and there's a phenyl group on number 1. Is that right? So 1 phenyl propane works fine. Either way, like I prefer propylphenol. Propylbenzene. But you can name 1 phenyl. What? Propane. Does it make sense, guys? Okay, 1 phenyl propane or propylbenzene. They're both correct names. I don't know if there's a preference anywhere. Okay, I prefer propylbenzene. Make sense, guys?
It was propyl benzene, and then what was the other one?
1 phenyl propane. Okay, I named this one as a chain, propane. And then this is the group phenyl. So at number 1 carbon, so 1 phenyl propane. Make sense? Good, all of you? Okay, number 2, why is that? Again, you have to explain. Okay, when you study. Number 2, 2 groups, one of them is what? Methyl. So the whole molecule is what? Toluene, right? And if that's toluene, then this carbon is what? 1. So this carbon is 3. So we call it 3-bromo toluene, or M-bromo toluene. Okay, M is what? 1 and 3. Okay. Letters only works for 2 groups. Okay, OMP only works for 2 groups. Okay, that's for sure.
Can you say that name one more time?
3-bromo toluene, or M-bromo toluene. Make sense? Okay, number 3. 3 groups, all what? Bromo. So what? Tribromobenzene. Is that right? And we have to tell where are they? 1, 2, 3, 4, 5. So what? 1, 3, 5. Tribromobenzene. Very good. Beautiful, guys. Last one. 3 groups. One is what? COOH, which makes this molecule a benzoic acid. Okay, you will see this a lot in chapter 5, later chapters. Okay, this is the benzoic acid. If that's benzoic acid, then this carbon is what? 1. So that's 3 and 5. So 3,5 dibromo benzoic acid. Very good. Okay, there's a space between benzoic and acid. Okay, benzoic acid is 2 words. But bromo and benzoic, there's no space. Okay, let me write it down. Last one. 3,5 dibromo benzoic acid. Okay, benzoic acid. 3,5 dibromo benzoic acid. There's a space between benzoic and acid. Make sense? All of it? Okay, again, guys, you have to explain. Okay, like you can study together, explain to each other. That's great. I love that too. Okay, love that too. Help each other and then explain to each other. You will make better, both of you, hopefully. Okay. So that's for naming. That's most of the important part. We're almost done. And finally, I want to show you guys a few more examples of aromatic compounds. These are just some. Aromatic compounds are a huge class of compounds too. In this class, most of them, of course, you see as the naming those one single benzene rings. But there are compounds with multiple benzene rings, like these fused together. You can see that? Some compounds, 2 benzene rings, 3, 4, 5, there's multiple benzene rings fused together. We call those polyaromatic compounds, or polyaromatic hydrocarbons, PAH. You can search that. PAH is a huge groups of compounds. Okay, those aromatic compounds, okay, can remember, most of them are carcinogenic. Okay, they're very toxic. Okay, they're very toxic. And where are they coming from? If you're burning something organic-wise, okay, burning plastic bags, burning your trash, doing barbecue, anything, if you're putting heat on some organic materials, there's a chance when you smell something very bad, are things containing these polyaromatic carcinogens. Okay, the reason is these compounds are extremely stable. Benzene ring is stable already. Multiple of them are fused together. The pi bond is even bigger. The molecule is extremely stable. That means if it gets in the human body, they're hydrophobic. So you can get them out. You cannot pee them out because they stay in your body, fat, liver, forever. Maybe for the rest of your life. Okay, and because of that, most of them are actually cancer causing. Okay, very cancer causing. And so these are some activities shows you can see that. Exhaust, burning, you put some epoxy or something, painting or something, it will cause the generation of these compounds. And these are some models of these. You can see how stable they are. Carbons fused together with a huge pi bond in their structures. Okay, but again, these are even these are a small group of aromatic compounds. We have a lot of aromatic compounds, and your medicines, your current clinically used medicine drugs, there are also a lot of them are aromatics. Okay, what we have seen is very small, typical examples show you what they are and what these terms are, and some basic info. If you're known later on, you will see more compounds like these. Okay, but aromatics, because of the benzene ring, because of the pi bond, extra stability of the pi bond, They are different than any other compound we've studied. That's why we have two separate words, aliphatic and what? Aromatic. Okay, so that's all for chapter 2. Okay, can you stop? Okay, do you guys